Hello guys, thanks for watching my video today. I would like to prove an interesting integral. Okay, what we are trying to prove is integral from 0 to pi of x sine x upon 1 plus sine x dx, which is pi times pi by 2 minus 1. Okay, so to prove this, I is equal to integral from 0 to pi x sine x upon 1 plus sine x dx. Okay, now using the property of definite integral, then is integral from 0 to a f of x dx is integral from 0 to a f of a minus x dx. Okay, so I is 0 to pi of pi minus x sine pi minus x upon 1 plus sine pi minus x dx. Okay, so which is integral from 0 to pi minus x, and sine pi minus x is just sine x. Okay, because using the law is a s t c. Okay, we used to remember the sign of this one. This is 0 and slash 2 pi, meaning 360. This is pi by 2, and this is pi, and this is, I think, 3 pi by 2, right? Yeah, this is 3 pi by 2, I think, maybe. Okay, now in this, a mean all meaning all the trigonometric function. Okay, sine, cos, tan, cosine, no, sine, cosine, tangent, cotangent, secant, cosecant. Okay, this at this first place, I mean between 0 and pi over 2, if they are lies here, they are all positive here. Okay, and again, if you come back to the second quadrant, this is quadrant or not? Okay, if you come to this second, this is s only. Okay, then is s is sine. Okay, sine and cosecant. Okay, sine and cosec. Okay, for this is for sine and cosec. In this field, only sine and this cosec will be positive and other will be negative. Okay, example like cos pi by 2, okay, plus x is right, cos pi by 2, so it is pi by 2 plus x, so it will be negative sine x, something like that. Okay, and here t means tan, here tan and cot. Okay, tan and cot will be positive, and here cosine and sec. Okay, secant will be positive and other will be negative. So here sine of pi minus x, so this is pi, so pi minus x means it is between here, right? It is in the second quadrant, so it will be sine will be positive, right? So it is, I mean, this does not change, so sine x upon 1 plus sine x. So I is now taking this to pi times integral from 0 to pi sine x upon 1 plus sine x dx minus 0 to pi x sine x upon 1 plus sine x. So this is exactly the same as our original I, right? So this is I is equal to this one. Now 2I is equal to, meaning adding both sides I. Okay, 2I is equal to pi integral from 0 to pi x sine x upon 1 plus sine x. So which is, now if you want to change this one, okay, this is from 0 to pi, so I'm going to change from pi by 2. So, and there's a property in log. Okay, that integral from 0 to a, 2a is equal to 0 to 2 times 0 to a. Okay, this is a property of definite integral. So from this you can change that 2 pi integral from 0 to pi over 2 sine x upon 1 plus sine x. Okay, now adding and subtracting 1 here, I is equal to pi integral from 0 to pi over 2 1 plus sine x minus 1 upon 1 plus sine x. Okay, adding and subtract 1, it will not change. Okay, so which is pi integral from 0 to pi over 2, so this and this will get cancelled, 1 minus 1 over 1 plus sine x dx. Okay, so which is I is equal to pi 0 to pi over 2 dx minus integral from 0 to pi over 2 dx upon 1 plus sine x. Okay, I is equal to pi times integration of dx is just x, so from 0 to pi over 2 minus integral from 0 to pi over 2 dx upon 1 plus sine of pi by 2 minus x, using this property again. Okay, using this the same property here again. 1 plus sine pi by 2 minus x. I is equal to pi times this one, pi by 2 minus 0 minus integral from 0 to pi over 2 dx upon sine of pi by 2 minus x. Okay, sine of pi by 2 minus, meaning it will be the first quadrant. So in first quadrant all will be positive, right? So that's why in is cos x. Okay, in is positive sign. Now so continue here. Now since double angle formula of cosine, okay, cos 2x is 2 cos square x minus 1, which is implies that cos x is equal to 2 cos square x by 2 minus 1, okay, which is 1 plus cos x equal to 2 cos square x by 2. Therefore our I is nothing but pi times pi by 2 minus integral from 0 to pi over 2 dx upon 1 plus cos x. So 1 plus cos x, okay, this is 1 plus cos x, so replacing that one, 2 cos square x by 2, okay, put x by 2 is equal to y, so dx by 2 is equal to dy, so dx is 2 dy. So I is pi times pi by 2 minus, here this will be 1 by 2, okay, 1 by 2 integral from when x is 0, so y is 0, when x is pi by 2, so y will be pi by 4, okay, and dx is 2 dy upon cos square y, okay, cos square y. So this 2 will get cancelled again. So I is pi times pi by 2 minus integral from 0 to pi over 4. So 1 over cos is nothing but sec, okay, sec square y dy. So we know that the derivative of tan x is sec square x. So therefore I is pi times pi by 2 minus integration of sec square x will be tan x, okay, tan x from 0 to pi over 4. I is pi times pi by 2 minus tan pi by 4 plus tan 0, which is I is equal to pi times pi by 2 minus 1 plus 0, which is pi times pi by 2 minus 1. Therefore our integral I did 1, so then is integral from 0 to pi x sin x upon 1 plus sin x dx is pi times pi by 2 minus 1. So that will be the solution, okay.